discussing the module 8 of the Organic Chemical Technology course, which is about the polymer, elastomer and synthetic fiber. And in the previous 3 lectures we discussed about the nylons, we discussed about the nylon 6, nylon 66, polyester, then the acrylic fiber, and how the development that has taken place in these sectors, and how it has played important role in meeting the synthetic fiber demand of the growing population. So now today I will be discussing about the viscose rayon, acetate rayon and Cuprammonium rayon, which is one of the very important sector in case of synthetic fiber, and because of its very good quality and the appearance like the silk rayons that has been in use. And the only thing that in here the difference, because in case of the all the other synthetic fiber, which is we call it the true synthetic fiber or the man-made fiber, that is the nylon or the polyester or the acrylic fiber, which the raw material, major raw material is from the petrochemical. Here the rayons are based on the cellulosic raw material, good quality of the cellulose, having high alpha cellulose, less semicellulose and the pentosone. So these are the some of that is the basic difference. In the here we are dependent upon the natural raw material. So the coverage of the lecture, that will be on the introduction, properties of the viscose rayon, Indian capacity of the viscose rayon, application of the viscose rayon, then the process detail of the viscose rayon manufacture, then we will be discussing about the acetate rayon and the Cuprammonium rayon. Although the amount of the total capacity, if you see the production wise, it is more in case of the much more in case of the viscose rayon than the acetate and Cuprammonium rayon. But some of the other raw material definitely that will be from the petrochemical route. This is, you can see the viscose fiber, how it looks like, and it is just like woolen material or the acrylic fiber, you can say. And the brightness, you can see the brightness of the fiber also. And because of the more and more comfort we are having in case of the viscose, now the use of the viscose in the textile, that is increasing day by day. This is also the this is the acetate fiber, which was this is also the silk like appearance we are having. So the rayon is made from cellulose derived from natural occurring material, especially the wood we are using here, wood pulp we are using in case of the rayon making. Some of the common rayon are the viscose rayon, acetate rayon and the Cuprammonium rayon. Amongst the various rayon, viscose rayon is the most commonly commercially manufactured rayon and find wide application in textile, tire cord industry, because as I told you earlier also that the tire cord that has been one of the major consumer of the synthetic fiber, but with the coming of the other fibers, the petrochemical based synthetic fiber, now more and more polyester, or it may be the polypropylene fiber, or it may be the your nylon fiber that is going to tire cord industry. But the importance definitely because the viscose that was available earlier, then the coming of the these nylons, or it may be the acrylic fiber. So the importance of the viscose rayon is both in the woven and non-woven industry. Various types of the viscose rayon, and that we are having the regular rayon, high tenacity rayon, high weight modulus rayon, flame retardant rayon, super absorbent rayon. Viscose rayon has a silk aesthetic with super depth and the feel, and retains its rich brilliant color, which I show you in the diagram, the picture of the viscose fiber, brilliant color. It has high moisture absorbency similar to cotton, because and this is the reason why we are consuming more and more viscose blend along with the, it may be the acrylic fiber or it may be the polyester, because the cost of the viscose is less than the cotton. breathable, comfortable to wear and easily dye. Because in the earlier stages of the coming of the man-made fiber, dyeing was also a problem for the synthetic fiber, especially the polyester, the nylon, and the lot of this development that took place in case of the dye manufacture also, and so the dyeing that was the more easier in case of the synthetic fiber with the coming of the new breed of the dyes. So in case of the viscose rayon, it is comfortable, soft skin, and has moderate, because that was this softness that was a problem in case of the polyester when it came into the market, because most of the textile 100% polyester suitings, 100% polyester shirts were there, and so that was not comfortable. So one of the advantage in case of the viscose, and now we will see in market the very soft textile materials are there, which is because of the viscose rayon. So soft skin and has moderate dye strength and low abrasion resistance, no static build up as in case of the other polyester and the nylon is there, moderate resistance to acid and alkali, excessive flammable, but this is the one of the disadvantage. Thermal property is poor and loses strength above 149 degrees, chars and decomposes it. So the melting point, this was the reason why they from the viscose to nylons or the polyester in the tire car industry, that was because what we need in case of the tire car industry, higher melting point, and that was the reason, because in case of the nylon and polyester or the acrylic, that is we are having plus 230 melting point as the sticking point. So that is the one of the disadvantage in case of the viscose rayon, that is the low melting point. Tenacity ranges between 2.0 to 2.6 gram per denier when dry and 1.0 to 1.5 denier when wet. It has poor crease recovery, because this is the one of the problem even in case of the cotton. But so for the crease is concerned, ironing properties there, it is better in case of the polyester or in case of the nylon, but in case of the viscose and the cotton, the crease problem is there in case of when you are using the case of the textile. So it has poor crease recovery and crease retention in comparison to the polyester, because of the low melting point, lower application in the tire cord that is there. But earlier when it was not available, the people were using the viscose rayon also, but you see now the speed of the vehicles that is increasing, and so the temperature rise is there, and so we need the more high temperature, high melting point material for the tire cord industry, and so that was the shifting from the viscose rayon to your polyester or the nylons. These are the various grades of the viscose rayon, types of the rayon: regular, high weight, modulus, high tenacity, microfibers, tensile rayon, the luxel. These are some of the trade name also. That is, these are some of the major actually the producer of the your rayon. One is the Century Rayon, that is because most of these companies are by the Birla group, because they are the pioneer in also the paper making. So Century Rayon, they are having the one unit is at Kalyan, another the pulp they are making at the Century Pulp and Paper, and that at Kashipur, that they are having one plant. Grasim industry, they are Harrier Polyfiber, these are the other which are making the rayon get pulp. Kesuram Rayon, they are making the rayon, Indian Rayon, National Rayon, Baroda Rayon, and so this is the domestic demand of the viscose. So the application of the viscose rayon: yarn, then embroidery, chenille, cord, novelty yarn. The fabrics: crepe, gardens, suiting, lace, outwear fabrics, and lining of the coats and the outwear. So these are the, in case of the fabric we are using, even the lining part is they were more your softness that is required. So lining part of the coats that we are having the viscose fabric. Apparel, dresses, blouses, sarees, jackets, lingeries, linings, hat, millinery, slacks, sports shirt, sports wear, suit, ties, and the work cloth. So these are the some of the apparel that we are making from the domestic textiles, bed spreads, bed sheets, blankets, curtain, draperies, slip covers, tablecloths, and the hosiery. Industrial textiles, high tenacity rayon is used as a reinforcement to mechanical rubber goods, tires, conveyor belt. So here actually the requirement that is the high tenacity rayon. So the tires, conveyor belts, hoses, application within the aerospace, agriculture, textile industry, and then the braided cords and the tapes. Miscellaneous uses that may be in the saws, casing, cellophane, and then the feminine hygiene. What are the raw material you see here you see the major raw material which we are using for the making of the whether it is viscose rayon or the acetate rayon, that is the cellulose. Then the caustic soda, carbon disulfide, sulfuric acid, titanium oxide to deluster the yarn, and then the sodium sulfide, sodium hypochlorite. These are the some of the other actually the raw material. One of the another important raw material that we are using the carbon disulfide in case of the viscose rayon, acetic acid and acetic anhydride in case of the other rayons that we are using. This is the requirement especially in case of the pattern of the rayon fiber of the various raw material, pulp, NaOH, H2SO4, carbon disulfide, zinc sulfide, because here the spinning, so that is the spinning bar that we are doing by the wet spinning. This is called the regeneration, wet spinning that is being done in case of the viscose rayons and other rayons. These are the various steps involved in case of the viscose rayon, that is the first step, that is the production of the dissolving, because the pulp which you are using, because we are using the pulp for making the paper and the newsprint, here the pulp which you are using for the making of the rayon that we call the dissolving grade pulp for high alpha cellulose, because what is happening, the even where the one of the process which you are using in case of we are treating with the caustic soda, so alpha cellulose, high alpha cellulose content that is required, and so that is the beta and gamma cellulose which is present that we are removing. So the steeping, pressing, shredding, aging, acceleration, ripening, filtering, degassing, extruding through spinneret and acid bath, drying, washing and cutting. So these are the steps, and each steps we will be discussing in detail, because there is importance of each and every step in the manufacture of the viscose rayon, because that will affect the quality of the viscose that we are making. First thing, that is the pulp which we are getting. What will be the source of this cellulose? Cellulose is used for the manufacture of the viscose rayon. So rayon grade pulp we call it, that we are using. So rayon grade pulp or dissolving pulp is the source of the cellulose. Dissolving grade pulp is made from the wood, and mostly it is the wood pulp that is preferred, and especially the softwood, but some eucalyptus, because the eucalyptus having the very good quality of the pulp, so that has been also used. So dissolving grade pulp is made from the wood. The pulp should have high cellulose, low hemicellulose with uniform molecular weight distribution, special bleaching sequence, because you see the lot of the deterioration in the quality and the strength of the pulp is there during the bleaching when we are using the conventional bleaching of the chlorine or the chlorine dioxide or the hypochlorite bleaching. Here we need this some of the other modified bleaching sequences for the making of the rayon grade pulp, and one of the is the enzymatic bleaching Also the oxygen chlorine dioxide at the oxygen delignification, that may be there, or it may be polysulfide pulping. So different type of the pulping process also there, but bleaching will have to take care so that the minimum damage is there, and at the same time the selective removal of the pentosane is also there when you are using the enzymes. So this is the basic requirement in case of the your rayon gate pulp. And you see the different, it is not the similar process which you are making from the broad process is same which you are making the pulp for the paper making, but here the special quality of the rayon gate pulp that will be required for making with the high alpha cellulose, hemicellulose, pentosane, all those, that should be minimum. So the first step in case of the manufacture of the viscose rayon is the stripping process. This involves the pulp sheets are placed in a stripping compartment and reacted with 18 to 20% NaOH at 20 to 22 degrees centigrade for about 1 to 4 hours. Because you see the purpose why the if you see the definition of the alpha cellulose, beta and gamma cellulose, so the alphas, beta and gamma cellulose, when we are treating with the 17.5% of the NaOH, so alpha cellulose that remains as such, and the beta and gamma cellulose they dissolve. So that is the reason of the keeping the 18 to 20% NaOH to then the what is the purpose? This is one purpose, to break the intermolecular bonds of the cellulose, to increase the solubility of the cellulose angsthenate, because finally we are treating with the carbon disulfide for angsthenation. So to convert the cellulose into alkali cellulose, because this alkali cellulose that further we are using the swell cellulose fiber, because the swelling of the fiber, and so the better actually the your reaction with the carbon disulfide that will be there to dissolve the low molecular weight hemicellulose. Then the next step in case of the viscose rayon manufacture is the pressing part. This is done to remove the excess liquid which is there, and so they finally after the pressing your cellulose that will go to the shredding and the white crumb that will be getting into the alkali cellulose obtained after pressing are laid to shredder at about 28 degrees centigrade for 90 to 120 minutes. This involves shredding of the pressing sheet which we are getting from the previous step to produce white crumb which is fluffy, which allow air to penetrate effectively inside. So because if you are taking as such the pulp, if it is not floppy, then the reaction, accentuation reaction which you are using in the subsequent stages, that will be not effective. So this part shredding and the making of the white crumb, that is also very important step in case of the viscose rayon manufacture. Then it comes the aging. After shredding, the white crumb are aged to bring down degree of the polymerization. This involves aging of the crumb through exposure of the white crumb to oxygen. It helps in maintaining the proper viscosity. This is the next step after your shredding. This is the main reaction which is taking place in case of the viscose rayon, and that is one of the very important reaction, that is accentuation, where we are reacting with the carbon disulfide. After aging, the soda cellulose crumbs are fed into airtight rotating churns. This is also churning process. The process involves treatment of the white crumb with carbon disulfide under the control condition at 20 to 30 degrees centigrade to form a cellulose angsthenate. This is called the yellow crumb which you are getting, and this is going for the further processing to get the viscose rayon. The yellow crumb is dissolved in caustic soda to form viscose. Then the next step in case of the viscose rayon is the ripening, filtering and de-aeration. The process involves ripening of the viscose by keeping it for 4 to 5 days at low, because here the low temperature is there, and so that is also one of the important requirement in case of the viscose manufacture. By keeping this various type of the fibers being made, roughness measured by the Horton number, that is one of the number of the roughness is there. After ripening, the ripened viscose is filtered and degas. Degassing is another step there to remove the air bubbles which is there. Now let us discuss the spinning of the viscose, because as I told you here what we are doing this wet spinning, and this is also called the regenerated cell fiber. So spinning of the viscose is done by wet spinning by passing through spinneret in acid bath, resulting in formation of rayon filament. This is the your bath composition: sulfuric acid, sodium sulfate, glucose, zinc sulfate and water. This is the composition of the your bath in case of the spinning bath, which we called it the sodium sulfate precipitates sodium cellulose acetate into filament form. This is the 5 sodium sulfate that is being added, and acid converts it into cellulose. Zinc sulfate gives added strength. Further processing involved after the your this rayon is formed or the yarn is formed. So what is the next step? Further processing involved washing, desulfizing, bleaching, conditioning and drying. Drying and cutting. Drying is the process of stretching the rayon filament, which straightens out the fibers, because this is one of the very drying in all the case of the fiber. Drying is very important, and you to give the your strength to the yarn. The continuous yarn is cut into staples for producing staple fibers. What are the various variables involved in case of the viscose rayon? Because the spinning process, temperature and composition of the bath, speed of the coagulation, length of the immersion, speed of the spinning, stage imparted to the filament, because that is, as I told you, the stage imparted to the filament, that is also very important. So these are the some of the parameters which are affecting the your spinning process. This is the reaction that is taking place, and the cellulose with the NaOH, then it is the sodium cellulose that you are getting, and after reacting with the carbon disulfide, cellulose acetate, and this cellulose acetate again we are getting the regenerated cellulose and in the form of the yarn. So this is the process which I discussed about the manufacture of the viscose rayon. The cellulose sheets, in the form of the sheets we are getting the pulp, and that sheet or the pulp sheet or cellulose sheet, whatever you say it, this is going to the steeping and press section, then the shredder, alkali cellulose aging tank, actinium reaction where for regulating the viscosity, feed tank, dissolving tank, filtration, ripening, deaeration, that is removal of the air bubbles, and then the viscose spinning. This was actually the steps which we discussed in detail earlier, and so this is a process flow diagram, and then the viscose spinning, that will go to the spinning bath where your viscose fiber that will be getting. This is about the it is going to the coagulate bath, that is the makeup tank where H2SO4 and N2SO4 that is you are adding. So this is the washing, desulfization, the bleaching and the conditioning and drying. These are some of the other steps that are involved. Now let us come to this was about the viscose rayon. You see the viscose rayon, as I told you, that is one of the very important part of synthetic fiber which we are using in our daily life. Another type of the rayon which was produced earlier, that was the acetate rayon, and this is just appearance, silk like appearance. It is just like the synthetic silk we used to call it, and we are calling the acetate rayon. Acetate rayon is the another cellulose based man-made fiber and has silk like appearance. The raw material is cellulose, acetic acid, acetic anhydride. Again the acetic acid or acetic anhydride that can be from the alcohol route or it may be from the petrochemical route. Here the purified cotton linters, where the cotton linters are cellulosic material, both the pieces of cotton linters that the fiber is more stronger than the cellulose, is fed to the acylator containing acetic anhydride and acetic acid and the concentrated sulfuric acid. Acetylation is carried out at 25 to 30 degrees centigrade. So, this is the reaction mixture called the acid dope is allowed for ripening for about 10 to 20 hours. During ripening, that is the conversion of the acetate groups takes place. After the mixture is diluted with water with continuous stirring. During the process, flax acetate rayon is precipitated, which is dried and sent to the spinning bath, where dry spinning of the acetate rayon takes place by dissolving in the solvent and passing through the spinner. So, that is not the regenerated as in case of the viscose rayon we are doing the wet spinning. Here in case of the acetate rayon we are having the dry spinning also. The solvent is evaporated by hot air during the this spinning process, where because it will pass through the number of holes are there spinnerage and the continuous yarn that will be getting and the drying of the removal of your solvent that will be there. Activation with the acetic. The process involves steeping of the purified cotton in acetic acid, which makes swelling and makes the cellulose more reactive. So, that was the purpose of the activation with the acetic acid. Acetylation, already we discussed this part, the pretreated cotton and the acetic acid is then acylated with the excess acetic acid, acetic anhydride with sulfuric acid to promote the reaction. So, 1 part of the purified cellulose, 3 part of the acetic anhydride and 5 parts of the acetic acid, that is the combination sulfuric acid as catalyst 0.1 part. Reaction is exothermic, the temperature is around 20 degrees centigrade for first hour and 25 to 30 degrees centigrade for the next 7 to 8 hours. Then the hydrolysis of the triacetate. The triacetate form is hydrolyzed to convert triacetate to diacetate. The resultant mixture is poured in water to precipitate the cellulose acetate fiber with the degree of polymerization 350 to 400. Properties of the acetate rayon: the tenacity 1.4 gram per denier, melting point 230 degrees centigrade and decompose when melted, readily soluble in acetone, methyl ethyl ketone, methyl acetate, ethyl acetone, chloroform and the ethylene chloride. So, this is the spinning. Already I told you the spinning is dissolved in the acetone that you are using as a solvent, and then the filter, deaerate, pass through the spinneret in hot air environment which evaporate the solvent. So, that is the spinning process, dry spinning process that we are using. So, low cost and availability. Here actually as we are using huge amount of the acetic acid and acetic anhydride. So, the some of the economical production that will depend upon the low cost and availability of the acetic acid and acetic anhydride. Recovery of the acetic acid, that is very important in case of the, as in case of the polyester also the recovery of the acetic acid, that is very important. Here the recovery of the acetone that we are using for the spinning, that is that has to be recovered effectively and economically. So, these are the some of the issues involved in case of the, and one of the major problem that has been in case of all the rayons, because we are using the forest raw material, means the wood for making of the pulp. So that is from the environment point of view and the deforestation point of view. So this is the process which I told you, the acetic anhydride, H2SO4, acetic acid and the pulp, and the here acetylated the cotton linter or the wood pulp, that is going to the acetylation, and then it is going aging, precipitation, centrifuging and the cellulose state for spinning, that is going where we are doing the dye spinning we are doing. This is the reaction that is taking place during the acetylation. Now let us come to the another important class of the your cellulosic base rayon, that is the Cuprammonium Rayon. Although the amount of acetate and cuprammonium is much less than what you are having in case of the viscose rayon, but these are the, apart from this rayon, some other rayons are also there which are made from the natural fiber, that is just like alginate fiber, soybean fiber. So all those things are, that is also there. But let us discuss now the Cuprammonium Rayon. Cuprammonium Rayon is made from reaction of cellulose with copper salt and ammonia. After bleaching, cellulose is added to the ammoniacal solution of copper sulfate, resulting in formation of cuprammonium cellulose, which is spun into water, and the yarn is washed with acid to remove the trace of the ammonia and dye. So this is the method which we are using for the, and if you see the here also the shredding and the cleaning, caustic digestion, sodium hypochlorite for bleaching that we are adding. In case of this is the wood pulp, the cotton linter that is going. So this is the after the shredding, because the more effective reactions may be there, and so the caustic digestion after the shredding that is being done, mixing and dissolution, filtration, spinning, washing and dyeing. So this is the process that we are using in case of the cuprammonium. So this was the actually the about the various rayons that we are manufacturing, and as I told you in the beginning also, the viscose rayon that has played very important role in meeting the demand of the textile industry. And again now you are finding the trend in the market is to use the more viscose rayon and the various blends of the polyester or the acrylonitrile, because the cost point of view and at the same time more comfort is there when you are having the viscose rayon. So the one of the actually the major issue that has been in case of the your viscose rayon plants, all the viscose rayon plants, because here which I forgot to tell you, we are using huge amount of the caustic soda, and that caustic soda now the most of the viscose rayon manufacturing, they are having their own caustic chlorine plant. And earlier, as you see, the before coming of the membrane faucet, it was only the mercury cell faucet that was being used in the making of the caustic chlorine. So the in case of the all the plants, one of the another issue that has been the where to go, where will be chlorine that will be. So chlorine handling that has been one of the major, because that has to be supplied to somewhere, because during the manufacture of the caustic. So this was the one of the issue. Another issue in case of the viscose rayon, the your environment point of view, because you see the in case of the carbon disulfide that is highly toxic, and the smell of the carbon disulfide that is there in the plant. So one of the major issue that has been in case of the viscose rayon is the chemical part of the chemical manufacturing unit of the viscose rayon, because normally they are having the in case of the any viscose rayon unit, that will be the one the carbon disulfide unit, caustic chlorine plant, and then the finally the viscose rayon manufacturing. So just like you take the case of the Nagda, they are having the membranes also. Most of the now the caustic chlorine plant, they have been converted to membrane based caustic chlorine plant, but the issue of the this chlorine that remains there. So this is one of the factor which is affecting the cost of the viscose also.